Hello, today we are covering 4.7 Quadratic Formula Part 2. If you recall from the previous video, the quadratic formula is x equals negative b plus or minus radical b squared minus 4 times a times c all over 2a. So we are going to use this equation to solve for the x values, obviously, because it says x equals. So, on this first problem, we are going to go ahead and state what a equals, b equals, and c equals. So I know a is equal to 1, b is equal to 3, and c is equal to negative 2. I'm going to copy my equation down. And from here, I'm just going to replace the information I know. So if I know b is equal to 3, I'm going to put 3 in here. If I know a is equal to 1 and c is equal to negative 2, I'm going to insert those in where they go. So I just replaced my letters with the numbers that correspond. Now, previous lesson we talked about the discriminant. We are once again going to solve within the discriminant first, and then we will finish it out. So I'll solve or simplify within the discriminant, but bring down the rest of my information like such. So 3 squared is 9, minus 4 times 1 times negative 2, so that becomes plus 8. Now I can go ahead and say negative 3 plus or minus root 17 over 2. A radical 17 is not reducible, so I have my two solutions here. You can either write it like this with the plus or minus symbol, or if you prefer to see it written out, negative 3 plus root 17 over 2 and negative 3 minus root 17 over 2. That is the same thing, okay? So those are your two solutions. Notice the answer to our discriminant was a positive 17, so we know there are two real solutions based on the discriminant. All right, our next problem. Recall, we always have to have it equal to 0. So right now this is not equal to 0, so I need to make it equal to 0. So I'm going to subtract 2x on both sides and add 9 on both sides. So I end up getting 4x squared minus 12x plus 9 is equal to 0. Now we know this is in the quadratic part of our lessons, which means we probably should not even try to factor or use slip and slide. It's not going to work. So instead, we are going to just go ahead and use quadratic equation, the quadratic formula. So we need to figure out what a is. A is 4, b is negative 12, and c is 9. Go ahead and write your equation out. X equals negative b plus or minus radical b squared minus 4ac all over 2a. Once again, replace my information. My b's, I'm going to put in negative 12 there. My a's, I need to plug in 4. I'm going to put them in parentheses so I know I'm multiplying. And my c, I'm going to plug in 9. From here, I am going to simplify what I can. I know negative 12 is positive 12, plus or minus. I will do some discriminant stuff in just a minute, but I know over 2 times 4 is 8. And my discriminant, I have negative 12 squared. Negative 12 times negative 12 is 144. And then I know negative 4 times 9 is negative 144. So my discriminant on this problem is actually equal to square root 0, which is simply just 0. So 12 plus 0 over 8 and 12 minus 0 over 8 are going to be the same thing. That is 12 over 8. When our discriminant is 0, we know we have one real solution. So x, if we reduce 12 over 8, is equal to 3 over 2, because I could divide them both by 4. And that is it. One real solution when the discriminant is equal to 0. All right. And the last problem. We can go ahead and subtract 5 on both sides. We want this to equal 0, so we have negative x squared plus 4x minus 5 equals 0. Figure out what a equals, b equals, and c equals. So a is negative 1, b is 4, c is negative 5. Write out my equation. X equals negative b plus or minus radical b squared. Make sure you know this equation is very useful. Minus 4ac all over 2a. Now the reason I'm writing everything so far apart is so that way I can do replacing pretty easy. So b is 4. So plug it in everywhere I have a b. A's are both negative 1, and c is negative 5. So when I reduce this, I have negative 4 plus or minus, well, let's work within the discriminant. 4 squared is 16 right here. Negative 4 times negative 1 times negative 5 is negative 20. All over 2 times negative 1, which is negative 2. From here, finish simplifying within my discriminant. Negative 4 plus or minus radical negative 4 all over negative 2. Now, if you recall, if we have a negative discriminant, we have no real solutions. We can still find imaginary solutions, which is what we are going to do. We just have to remember how to do that. So if we have root of a negative number, we can split this out into negative 1 and the positive number. We know root of negative 1 is I. Root of 4 is plus or minus 2. Now the plus or minus is already covered here with this plus or minus, so we don't have to worry about that. This is good to go. Anyway, I want you to recognize that this is not I plus or minus 2. These all go together because they're being multiplied here. Multiplied. So we now have this replacing root negative 4. We have negative 4 plus or minus 2i, because root negative 4 is the same thing as 2i, over negative 2. If you recall from a couple lessons ago, if both of these are reducible by negative 2, do it. You could even split it out, negative 4 over negative 2 plus or minus 2i over negative 2. They are both reducible, so we are going to reduce them. We have positive 2 plus or minus I. Notice this does become negative I, but they are covered both in this plus or minus, so we don't have to say plus or minus negative I. So x equals 2 plus I and x equals 2 minus I is our solutions for this problem. So there are two imaginary solutions and no real solutions. I do want to point out one side note here. If you end up getting an equation that says something like 5 plus or minus root 36 over 2, this is just an example here, we actually could have factored this sort of problem because root 36 is actually 6. So this is equivalent to 5 plus or minus 6 over 2. And then you want to do both problems. You want to do 5 plus 6 over 2 as well as 5 minus 6 over 2. And you'll get 11 over 2 and negative 1/2 as your two solutions for this problem. So that's just a random side example. If this is a perfect square, go ahead and finish solving for fractions or whole numbers, okay? That's all I have for you today. Have a great day.